Hi, I'm Zach Shelby, and welcome back to Machine Learning on the Edge. We're here at the Computer History Museum again to talk about what data and machine learning are doing for all industries: medical devices, automotive, logistics, consumer, you name it. And we're here bringing the leading executives and technologists from the world to talk about what's happening in this space. Today, I'm really honored to have Sean Hehir, CEO of BrainChip, the company that's bringing neuromorphic technology to the entire silicon industry. Sean, welcome.
Thanks, Zach. Glad to be here.
Now, I want to dive into the history of this technology. Not a lot of people know what neuromorphic is. People start to understand AI, think at a high level, what AI means, and kind of what the edge means. But neuromorphic has always fascinated me because of the connection with the brain. What's the backstory of neuromorphic and the BrainChip journey?
Great way to start. I always like to start at the beginning. Neuromorphic thought or technology or principles are really not that new. It was really established in the mid-'80s. And the concept about, if you think about the word neuromorphic, it's really based on how the brain processes. And the brain is a very efficient way to do processing. So computer scientists for a long time started to think, how can we mimic the brain to really take advantage of that kind of power of thinking and computation in the world? Once it came out, it was typically deployed more custom, very analog, very one-off type of thing, really not very practical in the world. And we even see that today with some of the bigger companies are out doing research, very kind of custom researchy stuff. With BrainChip, we decided to take the best of that neuromorphic principles, which is that very efficient computation engine, and apply it into mainstream technology. Let's take the best of both worlds. And as I like to think about this or talk about this a lot is, we always accepted the traditional way of doing things. Neuromorphic saying, why don't we do it smarter, do it differently? So we had two founders in BrainChip. One is Peter Vandermeer. We refer to him as Brain, and Anil Mankar, we refer to him as the chip. And so with Peter, he started to think very strongly about neuromorphic principles for a long time and how best to implement it. And he really cracked and worked really hard to get into a digital implementation. As soon as he got implemented and a couple proof of concepts, he quickly wanted to recruit Anil, who's a 30-plus year veteran in the semiconductor space, and started to create BrainChip. They worked for many, many years to deploy it. And so it's really the principles of the past brought into modern architecture of today.
Digital was a major leap here to go from this like researchy, super analog to the world of digital, which of course means we can fab it. Right? We can produce it at volume at low cost. What did that do? Right? What does that move to digital in practice do? I guess it bridges a gap between.
It brings it to mainstream technology, because you don't want to be technology just for technology's sake. You want to make it to a mainstream use case. To your point, you can produce it at scale. It's stable, it's predictable, all the things you need in mainstream technology. So that's the real key thing about us as a fully digital implementation on neuromorphic.
And what does neuromorphic do for us from a technology perspective? You think about AI developers, device OEMs.
Mm-hmm.
How should they think about neuromorphic at a very basic level? More efficient AI operator processing. But I'm guessing there's other things that come to mind for you.
Sure. A lot of it is efficiency, because the brain is so efficient. And really what we do in our implementation is make things, it's really event driven. So we take advantage of sparsity. We only compute on the change state of things. So it's always incredibly efficient, which translates to low power. And we'll talk a lot about power in the future part of our conversation. But lower power makes that incredibly powerful. Likewise, though, because it's so efficient, you can get tremendous performance. A lot of time people talk about the power elements of our offering, but the performance attributes are incredibly strong on the high end as well. So you've got that. And also allows us, we've got some very unique implementation around localized learning. Instead of learning and training up in the cloud, you can actually do an implementation and use case where you can learn locally, add a new class or a new object to something that you've deployed in the field. So some very unique benefits from this technology.
And now we're making this technology easy to use. And I think that's like the holy grail of all of this is let's put it in the hands of engineers. And so for anybody that wants to try this out, we recently announced full edge Impulse support, out of the box, multiple types of models running directly on BrainChip hardware. So go check that out, get yourself a kit, check out the performance yourself and what this neuromorphic technology can do. Sean, thinking about both of our backgrounds, I'm coming from ARM, where we believe in ecosystem. You ran ecosystem at HP. What does ecosystem mean for this edge AI industry?
Great. How much time we have? We could talk for a long time on this topic. You said it earlier. I ran all the ecosystem worldwide for Hewlett-Packard. I believe very strongly in the power of ecosystem, meaning no technology is an island unto itself. You've got to work with other partners, what I call to the left and the right, above and below you at all times, for the benefit of our customers. In the end, that's really what it's about. Not for your benefit, not for my benefit, for the customers. They want to know, simply, does it work in the total solution? And they want confidence that it will work. And only by working with partnerships, and we can talk about those type of partnerships in a moment, that you've tested, you've configured, you've documented, you've proven these things, they have the confidence to adopt your solutions as well. The other part that's really important is the easy part. If you look about any technology that you buy and any business buys, they want to ensure that they can deploy it easy. So the more you work with ecosystem partners, like our relationship, and they can see the ease of deployment, the ease of adoption, the ease of models, et cetera, they're much more confident in technology. So I think it's fundamental to our strategy. One of the first things I did when I became the CEO was establish that ecosystem strategy, resource it. We've got some great relationships, and we're going to accelerate that effort this year.
I think this is spot on. When we think about Edge Impulse and the journey we've been on, it's very much the same thing, right? Like our job is to make the deployment, the use of data and the deployment of custom AI models easy, accessible, commercializable for the end customers. And to do that, we need system integrators, silicon vendors, silicon IP vendors, device makers who can open up their hardware. We have people making gateways, cameras, right? Industrial sensor manufacturers. They need to open up their hardware for AI. There's this whole world of companies, hundreds of companies that we need to enable.
I'll add a few more, some consultants in there, some application providers, all these companies.
Yeah, so for people that are interested to check out the ecosystem in this space, Edge Impulse Imagine, the end of September, right here at the Computer History Museum, where we're a wonderful place to shoot and hold any event. People are welcome to attend and follow that show, because that's where we try to bring the whole ecosystem together. But thinking about the neuromorphic BrainChip ecosystem, what about people like foundries, the big architecture vendors like ARM? How do you fit into that ecosystem?
Absolutely. Well, let's take foundries to start. When you're an IP provider, people want to have confidence that it's portable, it can be deployed in any kind of technology fabric. And so, our first chip, because we do, even though we're an IP provider, we take our IP to silicon to prove it out, because that's another thing. Customers want to know that it actually works. So we have chips, we have kits, we have boards. They can take it, they can try it and say, this works incredibly well. Take a license and then design their customized chip in a very optimized fashion for them. So we have made a conscious point so far to work with two major foundries. We're also in a third foundry program that we announced recently, and we're going to continue to expand those relationships so our customers can have confidence that they're going to be able to deploy it in any kind of technology they want, right? That's because that's their choice to do. Around kind of processor companies and architecture companies, it's critical, again, to the comment I made a moment ago, they want to know that it works well, whether it's ARM that you mentioned or RISC-V. They want to have confidence that we work with them. So of course we work with them. We test, we configure, we document. So ease of adoption, because this technology will always work, particularly on the edge with those two companies.
Yeah, and it's really key from an architectural standpoint for people to understand that acceleration can be mixed and matched with so many different processor architectures. You know, neuromorphic acceleration plus ARM MCUs, right? Neuromorphic acceleration plus ARM CPUs, neuromorphic acceleration plus RISC-V, on and on, right? There's unlimited numbers of combinations of this, and we have to give silicon vendors that design space freedom, right, to solve different industry problems, going from automotive to wearables, for example, totally different types of goals.
Absolutely.
Let's talk about industries for a moment, because this is kind of where the rubber hits the road, right? We can dream of all the amazing acceleration and compute architectures, AI model architectures, but we really need to make industry executives successful in improving their business. Mm-hmm. What are the top 3 industries for you that are driving edge AI business right now?
I'll give you those 3, but I would simply start by saying I'm always surprised, pleasantly surprised, by the calls and the inbound calls from multiple industries. Now, I'll give you our 3 leaders right now, because at the end, as you and I have talked in the past, it's got to make practical business impact. And so the industry that we see the most are ones that are usually characterized by highly competitive, usually a leader in that market forcing change. The rest of the market, or the rest of the players in that market, need to compete. So they want to do things that are breakthrough in nature and allow them to do that. So the ones that we see the most right now are auto, for sure. If you think about auto, 2 major trends in auto. Every car is getting smarter, big push towards electrical. If you're electric, obviously low power in our offering is a critical part. If you're trying to be smarter, that usually means many, many sensors. It also means distributed compute. The idea of the days of a central's ECU or yesterday's thinking. Distributed sensors, distributed compute, uploading the metadata, managing it centrally, that's the model that cars are going for. So we're seeing a lot of interest in the auto vertical. The second one is industrial. And industrial is a broad category in the use cases around it, but there's a lot of things that are happening right there. Everyone is looking for that competitive advantage. And typically around the edge deployments in industrial, it's typical things about vibration analysis or sound or something local that you can react. And a lot of times the driver is preventive maintenance. What can we do? Look at a signature pattern, some sensor input, and say, oh, that'll keep this train on the track longer. It'll keep up our machinery that much longer. We can get more output. So you're increasing the top line and the bottom line at the same time. And then, of course, the home. Now, you put the home and medical all in that same kind of general bucket, meaning anything that we wear, perhaps, or small appliance in your home or small device. So the things on your wrist, the things in your ear, all very power sensitive, yet need very sophisticated models to do these things in a way that's there, untethered to the internet, perhaps. So those are the ones we see the most, but I'm always pleasantly surprised by the inbound calls. I'll give you a 4th one, communication devices, and I'm not talking mobile. Very interesting, a lot of innovation in communications right now. We're seeing a lot.
Walkie-talkie type things?
No, mainstream stuff, video conferencing as an example, things like that, where people say, how do I make my end product different and a better user experience for the end users?
Interesting. Well, that jives what we're seeing in the market. Medical and health wearable devices, so much going on. We have amazing customers. It's really driven by the clinical data that they can scale up with and the algorithm value that they're able to generate from that. For them, that is like the big value of their company, is why they're able to raise money, why they're able to go public, is based on that data and algorithm generation. So for those customers, they have a big driver to go and use edge AI technology. And then in industrial, in addition to predictive maintenance and sensors, we see a ton going on in industrial productivity and manufacturing. How can we make manufacturing more efficient a great case study we did was with Advantech in Taiwan. For their own manufacturing facilities, we put in a worker safety monitoring system with computer vision, just like overhead camera, not looking at the worker themselves and their productivity, but their safety. Because if there's a safety violation that shuts down a line, it's a disaster. And a lot of the management's time is spent looking over the safety of the workers. So if we can automate that process, they found very quickly that there was a 15% improvement in productivity for the whole facility because it freed up so much time from the management of the facility to concentrate on other things. But that's a lot of money, right? If you think about what a manufacturing facility can produce in one day, 10 to 15%. It's worth investing in data and AI.
Absolutely. We're just scratching the surface of great opportunity right now. It's interesting you mentioned productivity, what's going on here in the US with, are we going to go to recession, not go to recession? And they're wondering, how is the economy doing so well, yet with low unemployment? And it's the productivity gains are massive in this country, and it's going to continue with this kind of technology.
We talked a little bit about value proposition already, but I want to come back to that again, because as technologists, we kind of overlook this sometimes, right? We think about, wow, it'd be so cool to put an AI camera in this thing, or it'd be so cool to detect sleep on this wearable device, but it's not really how executive business decision makers think, right? So what do we need to do to really have this take off and become mainstream in device OEMs, in the end users of the technology? Like, what's the thing that's driving value? And especially in a market that's more challenging this year, right? We're having to justify value a lot more carefully.
Well, it's almost related to the last question, right? All businesses that approach us, and I'm sure with you, are looking for a couple of things. What is going to increase their top line? What is that going to give them a greater market penetration, or perhaps raise the price of their end product? So this is kind of technology, if it's a feature function, and they say, oh, I could charge 20% more if I had this feature function. Those are the conversations I have a lot with business leaders, not the technology. I have great people in our organization that have those. I talk to the business leaders saying, yeah, if we could do this, you could charge more, or you could gain some market share. They like that conversation. Or conversely, what can you do to help us on the bottom line? Some of the things you just mentioned. So as technologists, we often neglect that importance, which is translating that to the value of the enterprise. And we are spending a lot of time talking about those conversations I just outlined, which is, yes, this will help you. It's not just technology for technology's sake.
And one data point that I have, we work with a lot of teams that are trying to get into this technology space across these industries, right? They know they need to start making use of their data. They have access to valuable data, right? Whatever industry you're in, you're sitting on gold, which is your unique data from your business. Applying that data to algorithms is a big jump, right? The amount of skills you need, the ability to go deploy this on real accelerated edge compute that you need to take the benefits from power, right? Being independent on edge compute without having to go to the cloud. It's very hard to make that jump. So we're finding that just the teams that need to be built to take advantage of Edge ML can be in the size of 5 to 10 people with 12 to 18 months of infrastructure building just to have the tooling and deployment capabilities for just one piece of edge compute, let alone several generations of different silicon targets. That can cost anywhere from $3 million a year in just building up your own infrastructure, which is crazy if you think about the kind of cost savings we're going after are sometimes in the $1 million to $3 million a year. That's already a big win. If you're spending that much and just building up the base infrastructure, it's not really worth it. So there's a lot to learn about how we go apply this, how we make it easy. And I think this making it easy for the teams that exist, that are already skilled in the problems they're solving in their own business, and getting their time to market down as low as we can, right? Literally months rather than years.
I think that's a great way. In fact, when I gave you the answer to your last question, I wanted to talk about the ease of adoption and, quite frankly, why our relationship with Edge Impulse is so important to us. When I think of your company, I think of the things you just described as exactly what you're doing, making it easier, speeding up their deployment. These are critical needs in the market to help move it along that much quicker.
Awesome. Sean, thank you for joining me on ML on the Edge. I hope everyone enjoyed the conversation, really diving into what's happening with neuromorphic technology. Fascinating set of technologies. I think we only scratch the surface of what's possible with this. So I encourage everybody, check out what BrainChip is doing, check out the latest support that we have to go put it into real deployment and see for yourself what you can do with the latest in AI acceleration.
Thanks, Zach. Let's do it again.